Welcome to this afternoon's session on microservices minus the hype, how to build and why. My name is Mark Heckler. I am a principal technologist and developer advocate with Pivotal Software. Pivotal is the maker of Spring Boot, Spring Framework, Redis, Greenplum, RabbitMQ, Cloud Foundry, a huge contributor to Apache Tomcat, and many, many more things. We like to refer to it as a tiny little startup in Silicon Valley. I blog semi-frequently at thehecklers.org, my personal domain, and I tweet very regularly at mkheck. Is anyone here on Twitter? Everyone? Surprisingly few hands. I'm also a member of the slightly older and more established social network called Email, so if you see something I missed or if I rushed over something, by all means let me know. I'm always on Twitter, I live on Twitter, but I do check email from time to time as well. So I would ask, because I'm trying to fine-tune this a little bit. I've given this presentation a few times before, and I've kind of run this spectrum from all talk to mostly code, and I'm kind of coming back more toward the middle, quite a bit of talk and establishing the ground rules and the groundwork, and then kind of going into some code. It's pretty tight on time. I would ask you to hold your questions to the end if you can. And by all means, if we just run out of time or if you think of something afterward, I always think of stuff 2 minutes after I walk out too. So please reach out to me. Happy to discuss it further. So, a little bit of background. Who am I? I am the author of several blogs and blog posts. I've co-authored one book already with another one in the pipeline. And I'm a contributor to several others. I love to read, I love to write, I love to share information. I feel like no one has the market of knowledge cornered, and the more we all share, the smarter we all get, faster, which to me seems like a pretty good positive. I've spoken around the world on various development-centered topics, and thank you very much for inviting me here, by the way. Love Poland, and I have to tell you, this is a particularly special day for me. This is my anniversary, and my wife is in the US, and I'm here. So you guys mean a lot to me because I'm here actually spending time with you instead of at home. So I am married to perhaps the most patient person on the planet, and I hope she picks me up from the airport. We'll see. First and foremost, though, I'm a developer. I've worked for various consultancies. I spent a few years at Oracle, have the scars to prove it. Now, of course, I hang my virtual hat at Pivotal, and just like you, I use what works, and I do my best to fill any gaps when I find them. I love open source. I think it's the model of the present and the future, and while there are exceptions, they are certainly exceptions. Recently inducted Java Champion, recognized by my peers for contributions to the greater Java community. Very honored by that, and if you had anything to do with that, thank you very much. I've survived years of working on monoliths and have struggled with the same issues that you probably have, large, lumbering, brittle systems that infrequently update their production deploys, inflexible systems with inflexible configurations, and I'm always looking for a better way to deploy real software to production, software with real business value, not undifferentiated heavy lifting, as Adrian Cockcroft, formerly of Netflix, likes to say. So, today, I will be presenting in English for your safety. Listening to me trying to speak Polish is similar to listening to a Vogon try to recite poetry. Does anybody get that reference? Okay, good. Do you recognize this photo? Yes, you know what year? So you didn't know there was going to be a quiz, did you? Sorry, what did you say? Do you know what year this was released? Okay, 2005. I'm kind of a history buff, so throughout here I'll be showing some different movie and TV references and quizzing you a little bit. So I promise not to throw anything other than softballs. If I had a T-shirt, you'd have it, but sorry. So, okay. My goal today is to stay as close to a purely fact-based discussion as possible while throwing in numerous interesting or amusing TV or movie references at no extra charge. But there will be no straw men. And by that I mean I'm not going to set up easy arguments to knock down and claim victory. What I try to do is take a thoughtful look at things. Again, I survived years of monoliths. I was a hard convert to the microservices architectures, but I am a convert, so unapologetically, I lean that way. Here's a disclaimer, though. I am human. If anyone's goal here is just to find something with which to disagree, I'm sure I'll provide ample material for you. Please do disagree with me. That's fine. Ping me, let me know where I may have spoken out of turn or maybe just glossed over something. Happy to adjust as for the next time, so you can help the next crowd. But again, this is meant to be thought-provoking, informative, and mildly entertaining, and that's it. So does anyone recognize this reference? Photo quote. This is a little harder. This is from Dragnet. It's an old TV show that ran from 1967 to 1970 in the US, but it's on retro TV now. As a history buff, I kind of like to go back and watch the oldies. Sometimes they're kind of hard to watch, but they're fun. It's kind of like amateur anthropology and archaeology all in one. So anyway, what is our goal as developers? Regardless of what you may have heard, speed is not the goal. Velocity is the goal. And what's the difference? Well, speed is a scalar property. Velocity is a vector property. Okay, what's the difference, right? Speed is rate, is pace, but it has nothing to do with direction. So if I run forward and run back really fast in place, I've gotten nowhere. In fact, if I do it wrong, I may have actually lost ground. Velocity is sometimes referred to as speed plus direction. So what we want is to apply the same direction to every step we take, every movement. I'm coming dangerously close to quoting an old Police song here. But we want to make sure that we're moving out. Speed for the sake of speed is not a good thing. So, how'd that happen? Interesting. If we're going to be discussing microservices and trying to de-hype them and assess them critically, we kind of need to know what we're comparing them to, what we're contrasting them with, what the alternatives are. And that brings us to this. Typically, when we're looking at microservices, we're also comparing them to monoliths. Does anyone recognize this shot? Godzilla, you know the year? Oh, surprisingly, no, 2014. This is the latest one. Yeah. I mean, Godzilla's made several appearances over several decades in several media, but this is recent. So, as it says, that's one big app. What is a monolith? This is something that people wrestle with. To me, the easiest way to define a monolith is to kind of look at the characteristics. Typically, a monolithic application covers a lot of ground, a lot of different business functions, and it does so. It delivers all of these business capabilities via a single logical executable, whether it be a jar or a war in the Java world, or a deployment bundle, a directory, what have you. All of that functionality is provided by one deliverable, one deployable artifact, if you will. And as such, typically it has a shared data store, a shared data mechanism beneath it. Not by necessity a single database or schema, but that's usually the case. Because typically monoliths, you may have heard the concept of horizontal partitioning versus vertical partitioning. Typically monoliths are horizontally partitioned. So you have all of this capability which sits on top of a single database in some manner. As such, since you have one application that provides a lot of different capabilities, changes to the control flow changes are typically impossible to make without modification of that monolithic app, that single large application. There are exceptions. There are exceptions to every rule. Speaking of rules, you can have rules engines and things like that. But typically, I mean, that's another topic for another day that you could fill a whole talk with just that. But changes to the flow of control for a particular business process within the monolithic application requires a complete reassessment, rebuild of that monolithic app. And as such, modification of the app is non-granular. When you make a modification to one portion of that monolithic application, you're going to rebuild, retest, redeploy the entire application. There are tools, again, to get around this, but they are workaround tools to overcome acknowledged flaws or needs. In addition to non-granular app modification, There's also non-granular scaling. To scale a monolithic application requires duplication of all functionality within that application. Within any application or distributed application, there are certain components that are very heavily used, and there are other components that aren't used much at all. But with a monolithic application, when you scale that, you effectively duplicate all of that each time. So it's not terribly efficient. With a monolithic application, there's a greater attachment or commitment to a particular set of technologies. Because you're using a particular language, a particular platform like an application server, specific drivers or third-party libraries for everything. Everything is kind of in one deployed bundle. And there's a much lower cohesion and a higher degree of coupling. Even in the best of circumstances, when you have excellent architects and you have excellent developers and you have everybody trying their best to make sure that you have a good separation of concerns within a monolithic application, what happens when at midnight, California time, someone gets a call, a junior programmer gets a call to get the system back online before orders start flowing in from Europe within an hour or two? And this junior developer has a choice to make. They can either implement a very elegant solution in about 4 or 5 hours, or they can implement something quick and dirty in about 10 minutes. So does anybody want to take bets on which option is going to be chosen? It's going to be the quick and dirty, because if not, that developer is going to probably be looking for a job the next morning, because time is money. So even if you start out, the second law of thermodynamics tells you that, all systems tend toward entropy. So even if you start out with the best of all worlds, things are going to slide down pretty rapidly. Excuse me, gotta have to mute that when I do that. With a monolithic application, failure of a part of the application typically means failure of the whole. The best example of that I can think of is the data access layer. Again, since you're horizontally partitioned, if the database goes down, typically everything goes down. We've seen examples of that in the press lately. I won't mention names, but I'm just not going to go there. Anyway, you all know examples of companies who are writing on a single unified database and the disaster that can happen when that fails. So the one big upside of a monolith, when it's smaller anyway, is that it's much easier to reason about the entire monolith and all the capabilities it provides. The mental model is complete for a smaller system. Now here's the downside with that. How long does that monolith stay a baby monolith? How long does it stay reasonable? Because typically what happens is with every system we implement, things grow. User bases grow, companies acquire other companies, and field applications that were meant to be perhaps fielded at a much smaller level, at a much larger level, geographically distributed, so on and so forth. So that tends to complicate things a bit. Compared with microservices. As I say here, assemble to make more than meets the eye. Does anyone recognize that catchphrase or the photo? Quiz time? Okay, I heard Optimus Prime, and this gentleman, you recognize the movie? Transformers, yeah. 2007, I'll skip the years, but a forgettable movie. But anyway, so fair's fair. Let's take a look at the characteristics of, let's back that up. That's better, okay. Characteristics of microservices. Microservices are independently deployable and executable services. They are very focused. They provide specific application functionality. With regards to development, you can get velocity where needed and stability where not. There are certain components, there are certain pieces of functionality within your organization that don't change a lot from day to day, week to week, maybe even year to year, whereas there are other capabilities that are pretty fluid, that need updated frequently, and situations in the market dictate rapid updates. Control flow changes with a microservice architecture typically are trivial. And by that, I don't mean to say that they're easy, but you're looking at a composition-based process versus coding your entire business flow within a monolith. So again, is anyone here familiar with Dr. Eric Evans' domain-driven design concept of bounded context? Okay, within any system, within any ecosystem, you have certain divisions of functionality or boundaries that naturally fall out. If you have a warehousing system, it will obviously be somehow related and tied to your accounts payable, accounts receivable, things like that, but they're not directly overlapping. They have a very loose association. So these would be typically considered bounded contexts, separate contexts. And microservices built around different bounded contexts and built to maintain a published API extend contracts to other microservices. As long as another microservice exercises that API, what is within that microservice doesn't necessarily matter to its customer microservices. So control flow changes are trivial, whether it's via REST calls or messaging. You have pipelines that you can insert another context within, if you will. Changes are non-disruptive because, again, with that same bounded context, as long as you maintain that consistent API, no one else cares. The other microservices who leverage your service in question don't care. You've not broken the contract, everything's fine. Scaling is more effective and efficient. As with velocity, in which we develop and iterate quickly where needed, with microservices, we can scale what needs it when it needs it. Microservices also gives you what I call polyglot plus. By standardizing upon the APIs and contracts for interaction, it provides you opportunities to employ other languages, platforms, and even locations. So if it makes sense for you to use a different language, or perhaps deploy something in a public cloud versus on premises, you can do that with a microservice at a much lower risk. If you take your monolithic application within your organization today and decide to rewrite it in a different language, or field it on a different platform, or move it to a public cloud, how traumatic is that? How much risk is involved in that? You're betting the company, in many cases, on a single move. And with a microservices architecture, you can take that same type of decision and scope it down to a microservice or a small cluster of microservices. And if it doesn't work, your risk is much lower, because how long does it take to rewrite a small, well-defined microservice? Not long. So your risk is much reduced as well. With microservice architectures, there's a much higher degree of cohesion and a lower coupling, because again, it's not because people get better, it's not because they try harder with a microservice architecture, it's because there's an API-enforced separation of concerns. Failure of a microservice is isolated in a proper implementation. In fact, the whole architecture assumes there will be failures, so it's built around that, and I kind of get into that a little bit more later. Since they're small and typically stateless, they're very quick to spin up replacements if something crashes, if something goes offline, as well as having patterns in place like graceful degradation for circuit breakers and things of that nature. And this is kind of contradictory with something I said earlier, but there is a much more manageable mental model for a microservices architecture in the micro level. If you are bringing online a junior developer and they are having to get the keys to the monolith and make production changes within a week or two, how nervous are they going to be? How nervous are you going to be handing them the keys to that? Because they don't know, by making this change, how many ripple effects will be exposed. Versus with a microservice, if you, again, stay within the context of that API, that contract with your other microservices, you're insulated from a lot of the potential ill effects. The mental model is also much easier because you're dealing with a small bit of functionality versus the whole enchilada. Jeff Bezos famously called them two pizza box teams. You don't need better communication. You need actually less communication. You need better defined APIs. So sometimes you get the question, wait, isn't this just warmed over SOA? And the long answer to that is no. That's it. Oh, just kidding. They're conceptually similar, but the implementation draws a clear distinction. Martin Fowler has said a lot of interesting things over the years, but here are a couple that I particularly like on this topic. The microservice style is very similar to what some advocates of SOA have been in favor of, but the problem is SOA means too many different things. And most of the time we come across something called SOA, it's significantly different from the style we're describing here, usually due to a focus on ESBs, enterprise service buses, used to integrate monolithic applications. So what you typically have with SOA is you're introducing smart pipelines, so additional complexity, to existing monoliths. Doesn't sound a lot like microservices, does it? He goes on to say that the fact that SOA means such different things means it's valuable to have a term that more crisply defines this architectural style, or I would say accurately defines the architectural style. Another statement on it is microservices is an evolution of SOA concepts. The benefit of microservices over traditional SOA is speed and agility. For making changes, ability to make changes less overall cost, less impact to the existing infrastructure. It's a different approach with different uses of technology. So just to kind of compare them. There we go. It's a little sluggish on some of the rights. I refer to SOA as macroservices because, again, you're dealing with, in many cases, monoliths connected via enterprise service buses. So you're inserting new bottlenecks, smart bottlenecks, between your monoliths and calling it, in some cases, a faux microservice approach. So additionally, the protocol, the formatting of data exchange is heavier in general. SOAP accommodates or is able to accommodate a lot of different transports underneath. But 90+% of SOAP is implemented over HTTP. So the fact that it has to support JMS and TCP and UDP gives you nothing, but adds a lot of baggage. There's also more coupled ceremony because many, if not most times, producer and consumer code is generated from WSDL. And thus clients are tied rather forcefully to the API. So when the API changes, both backing services and clients must change in lockstep. Enterprise service bus products usually incorporate sophisticated facilities for message routing, coordination, transformation, and of course applying business rules. So as such, an ESB externalizes domain knowledge and incorporates process knowledge into the ESB itself, which ironically increases coupling while decreasing coupling. It's kind of a, it's not really a win, it doesn't seem. And all these points and much more make it pretty difficult to scale within a SOA environment versus microservices, which are more focused, but the downside being, of course, there are more of them. They're lighter as a general rule. Typically, REST is employed with JSON, can use XML, of course. We also can use messaging queues. But regardless of what it is, you have what are referred to as dumb pipes. You still have your smart endpoints and dumb pipes. There's much lower ceremony, there's much lower coupling because you adhere to the API contract, and the only requirement for success, again, is to not break that contract. Getting back to the smart endpoints and dumb pipes, a microservice owns its domain logic. So typically, a microservice receives a request, takes an appropriate action, and returns a response. So you're talking about REST or something similar versus WS Choreography or Beeple or other centralized orchestration tools. So whether you're talking about REST endpoint calls or message queues, they're streamlined, they're straightforward, they're dumb pipes, if you will. I always kind of look at it in terms of a comparison. SOA is more orchestrated, so like an orchestra performance. And microservices are more choreographed, like a dance performance. Everybody been to both? Either? In an orchestra, the conductor is up front and center in the performance, making sure everything goes right. So he's a very, or she's a very, central point of that performance and a very essential component. In a dance performance, where's the choreographer? Typically what happens is the choreographer works with the dancers to, if you will, impart the domain knowledge. To instill that domain knowledge in each of those bounded contexts, those dancers. So when the time comes for performance, they're up there on stage, they're doing their thing, they're following what their expertise provides, but adapting to the situation at hand, just like microservices. And of course, microservices are built to scale from the beginning. They're smaller, again, they're lighter, they have bounded contexts, they're API driven. So, what are some gains and losses? Because as with anything, there are upsides and downsides, right? Well, there are trade-offs, and some are somewhat contradictory depending upon the priorities of the business. You Gain scalability. You isolate high-demand modules, which means you can focus and scale those as needed much more readily. It's much more efficient by doing that, because instead of having to effectively double your hardware or double your cloud footprint, you can scale what needs to be scaled and only what needs to be scaled. You are much more effective because you can rapidly iterate nuggets of functionality and more accurately fulfill business requirements. In a monolithic application, typically you'll have somewhere between a 6 and an 18-month release cycle. Every time I ask this question, I'm always kind of surprised at the number of people who deal with a 12 to 18-month cycle, but it's pretty prevalent. So what are the odds that when you deal with a subject matter expert or a business domain expert, that you're dealing with the same person from day one that you are when you release, 12 to 18 months later? Not so great, right? And even if you are, what are the odds that the market has stood still that entire 12 to 18 months? Again, not good. With a microservice, with a particular bit of functionality, a bounded context, you can work through and develop that within a matter of weeks, days, hours sometimes. And you can get instant validation from your expert. So it's much more effective. Your velocity goes way up because, again, you can develop a small bit of functionality that's a cohesive bundle much better than you can add in something to the big ball of mud that is a monolith. You can also optimize based on your requirements at hand. So you can choose the best language, platform, database, what have you for that particular service. If the data that you're dealing with in that service lends itself well to a graphing database, use one. If you have certain requirements that typically lend themselves better to one language or another, use that. That's fine. And again, risk is low because if something doesn't pan out the way you would expect, performance isn't where you need it, you can swap that out very quickly and readily. Interoperability is high because as long as you adhere to the API, again, you're in. Availability with a microservices architecture is non-binary because the architecture assumes rapid multi-instance app deployments. With a monolith, typically it's either up or it's down. When you have a problem, it's very easy to find. The problem is in the monolith. But as such, when something breaks, typically the whole thing breaks. And then you get into this kind of unvirtuous cycle because when the monolith goes down, requests back up, right? So when the monolith comes back online, what then happens? It just gets slammed by all the requests that are coming in, which typically means that it goes down again. So you have this kind of up, down cycle. With a microservices architecture, when something breaks and you have patterns built into this, so you have graceful degradation, you can do throttling, you can do graceful degradation with a circuit breaker pattern. You have a lot of things that allow you to minimize the impact. If nothing else, you can keep traffic flowing at some reduced level throughout the entire time. Microservices give you independence. Again, you're not strapped to a particular platform or language. You can try different things. You can experiment. You can employ what makes sense at that time. And as such, it can yield cost savings, not by default, but because in a monolithic world, if you add users, if you add functionality, and perhaps you're dealing with a particular vendor or particular license costs, those costs go up, right? You have no choice in that matter. But when you can choose your technology, choose your platform for each microservice, you have a lot of choice. It can also lead to increased revenue. I don't know if you've ever heard of a tiny company called Amazon.com. 10 years ago, Amazon got no or next to no revenue from their cloud services. But at some point, Jeff Bezos and company decided to create everything as a microservice, to expose APIs for everything. And that leads many times to exploitable APIs, not just within your company, but with partners or with customers. So it can lead to opportunities for increased revenue as well. With microservices, there's less complexity, again, at the micro level, so there's a shorter ramp up for developers, new developers, and easier knowledge transfers. And of course, that gains you some control. Other things to throw out, lower complexity per unit. Test cases typically run against only targeted or changed modules versus having to run the full suite when changes are made to one segment of a monolith. And of course, faster deployments because you're targeting smaller apps and services. So let's see here. So what are some of the losses? Well, at the macro level, there is much greater complexity. All kidding aside, distributed systems aren't easy, and there's a lot more to take into account when you have a distributed system than when you have a system. To reap the full benefits, you're going to need better architects in your company. Now, here's the catch. You may already have those better architects, but they're operating within the constraints that your company has placed upon them now. So, I don't know. That's a potential downside. You also lose the single source of truth for your organization, which, to be honest with you, that's one of the things that people bring up first, because it's such, we've all been conditioned for so long to keep that in our mind that if we lose that single source of truth, we'll have chaos. How will we ever get an accurate picture of what's going on within our organization? I'm going to address that here in a minute as well, but typically it's not quite the showstopper that you would think it would be. The next loss is that change is hard. Organizationally, architecturally, we as human beings want all the benefits of change, but we don't have to go through any of the pain. But guess what? You're going to have to if you're migrating from a monolithic type of environment to a microservices-based architecture. And then, of course, greater complexity. And I know I mentioned that as the first one, but it bears repeating, because there really is no such thing as a free lunch. There are many advantages that a microservice architecture delivers, but they don't come for free. Greater complexity is probably the greatest drawback. So, has anybody ever heard of the Plato Principle? Nope? Okay. Has anyone heard of Plato? Modeling clay? Oh my gosh, I still have a can of this sitting on my desk. Think of these as microservices. These are bounded contexts defined by color, right? So each of these is a different microservice. And this is your monolith. Yeah, you know, don't you? So has anybody ever given several cans of Play-Doh to their kids and watched how they turn out within about 2 hours? They start off so pretty, the different colors right here, and they all wind up looking like this. And the Plato Principle basically states that it's always easier to combine small self-contained code or data than it is to decouple code or to parse data. And the reason I mentioned earlier that people always worry about losing that single source of truth is that what typically happens in a production environment on a single database? I mean, you run all your reports off your production database, right? You do your backups off your production database? Well, no, of course you don't. Talk to your DBAs and sysadmins. I mean, typically what happens is you have a production instance, or instances, cluster, and then you have a backup instance, or a reporting instance, or cluster, because you don't want to take a chance on dragging down performance of your production database. You'll have a similar type of situation with a microservices world, because you'll still be populating a combined view that you can do reporting off of to get that single pane of glass, or in all likelihood you will. It's not radically different, but that's the first thing that people tend to fixate on, and it's just not that much of an issue. It's a little different mechanism, but certainly the end result is the same. Again, it's easier to combine than to separate. So, what do I need to execute? Let's see, we're not doing horribly on time. I'm going to shift to demo mode. Does anyone recognize this? I would be shocked if you did. I just picked it out because I thought it was a really cool photo. But it's Shaolin versus Lama from 1983. Has anybody even seen that? I haven't. I'm not even sure it's even available. But again, great photo. So, realizing with the time constraints we have, what I'm going to do is kind of step through what I typically do some live coding. There's just not time. But what I do want to show you is some code that I've written and kind of step through the different concepts and how the patterns apply, because I'd like to kind of clear up some misconceptions when it comes to microservices. Let me switch back to mirrored mode. And let's see if I've got my buddy IntelliJ up. Okay. The first thing I'd kind of like to discuss is that when you have microservices, is anybody here a Netflix user? Netflix subscriber? Okay, good handful. You know the website, netflix.com. When you log in, you see a few different things on there. You see, hey, welcome, hi, Mark, in my case. You see recommendations for you. Here are movies that you might like. Here are new releases. Here are romantic comedies, action adventures, so on and so forth. Anybody care to guess how many microservices go into providing the information that is bundled on that single application page? Wild guess. How many? 30, okay. Anybody else? 42. Raise your hand. Okay, if I had a t-shirt, you'd have one too. Maybe two of them. How many over here? 600. Okay, you're close. It's actually about 500-ish. That's a lot of microservices, right? No. Just to provide the information that's on that. Oh, okay, I see what you're saying. Yeah. So, I mean, it's not insignificant, is it? Which gives you an idea of the scope of microservices. What are the odds that you think that any of those are running as a single instance? Probably pretty low, right? So let's just do some really simple math. Let's say that each one of those microservices runs about 10 instances. That means you're dealing with about 5,000 instances of microservices running at any given time. The real answer is obviously probably much larger, but this makes it easy for the math. So with that many microservices or instances of microservices running, best practice dictates that we have externalized configuration. We have our properties for backing service URLs and credentials and things like that externalized. We don't want those in our code base because, well, for several reasons. One, if we open sourced our code, we don't want to expose our credentials. Two, we want to be able to change out those settings without a rebuild and retest cycle and redeployment. So all of those configuration properties are now externalized, and that gets to be pretty hard to manage when you're talking 5,000 or 10,000 or 50,000 different instances of microservices you're dealing with. I do a lot of talks on Netflix OSS and Spring Cloud OSS and how they complement and correlate. Spring Cloud OSS includes a component called the Spring Cloud Config Server. What that does is it's a microservice that operates on top of Git or SVN, which serves up properties. That's its entire purpose in life. When a microservice knocks on its door and asks for its set of specific properties to it provides them. And a config server allows you to centralize those configuration properties without introducing a new bottleneck. Because when the app starts, when each microservice starts, it grabs those and caches those. It can be updated, but everything runs fine even if your config service goes down. So that's the first thing I'm going to fire up because everything else kind of depends on that, right? Every microservice needs its properties. And just a quick look, we see that it's running on port 8888. So if we go to our browser and I'm going to have to blow that up a little. Whoops. Localhost. Let's see. Oops. Yeah, so picky. And this allows you to define properties for all microservices as well as specific microservices with, of course, the more specific properties overriding the less specific, which is great. So we've kind of covered that, providing our configuration to our various microservices. Very easy to build. I usually do build this as kind of the first step in my sessions, and that's a couple minutes. But again, it all kind of adds up, and we're close. So the next thing that we typically need is some kind of a service registry. Just like the old phone books that we probably haven't used in some time, you need a place for microservices to see and be seen. These are not toys. When you're talking Netflix scale and any large organization scale, you're not going to be able to simply provide a few different ports or network addresses and have everything work. You want to be able to have your microservice reach out, find out where other microservices it depends on are located, and make the connection itself. Netflix uses a piece of software they wrote called Eureka. Spring Cloud OSS abstracts from that and allows you to use HashiCorp Console or Eureka or Cloud Foundry's Registry or Zookeeper. We're just going to use Eureka because, again, it's fast, it's simple, I can show it very quickly. It gives you a couple of different components. One, of course, is the ability for your services to register and communicate or find the other services. This is not an enterprise service bus. This is not a bus for everything to pass through. It's just a lookup. That's it. This is the dashboard, and this provides really no value to these microservices. It provides value to us, to human beings. A colleague of mine likes to call it meatware. This is for the meatware. It's not for the software. So Kote, if you're out there, thank you for that. So here, what you'll see over time is instances registered with Eureka. And you'll see your microservices registering themselves as well as their various instances. In a cloud environment, when an instance fails, when an availability zone goes down, I don't know if you're familiar with Netflix's Simian Army. They have Chaos Monkey, Chaos Gorilla, Chaos Kong, which either pulls off a virtual machine or pulls down a rack, pulls down an entire availability zone. These are things that Netflix does. It's all self-inflicted, but it makes their developers concentrate on survivability. When you have a very volatile or a fragile infrastructure, as they like to call it, like cloud services, an instance that was running here of a microservice may now be running here. And you need some way to keep track of that dynamically. That's your service registry. The next thing I'd like to fire up is a backing service. I created a quote service because, again, I'm a quote hound. I like quotes, pithy quotes, movie quotes especially are pluses. And I like historical quotes as well. I have a couple things that I can show you in this if time permits, but effectively what this does is create, basically I'm creating an application, I'm registering it with Eureka, I'm connecting it to via Spring Cloud Stream to RabbitMQ, so a message queue in the back end. I'm creating a JPA entity for quotes, defining a Spring Data REST quote repository that allows us to then tie our backing data source with REST endpoints and create those very quickly and easily, and then defining a REST endpoint. So just to fire that up, and actually let me make sure that I am running well, that's not encouraging. Docker seems to have crashed on me. Oh, nope, we're up and running. Okay, just took a little while. So I'm going to go ahead and run that. And that gives me an opportunity to show a couple other things, because again, we're talking industrial strength here. We're not talking about very simple, very hardwired toys. In fact, if you look at, this is one of the underlying properties files that relates specifically to a service called Edge Service that identifies itself as such to our config service and gets the properties for it. Let me blow that up for you. As you can see here, we've got Zool. Zool is Netflix's entry for intelligent routing. And this allows you, even with your monoliths, to break out the routing from your code base, to have your endpoints defined external to any code. You can reroute at any time. So as you splinter functionality off from your monolith, you can change your routing gradually or all at once. It also allows you to forward to public APIs or local endpoints. So it gives you quite a bit of capability in that regard. Let's see. And let's take a quick look here. So on our backing service, what we have is we return a list of quotes. I also, because I like quote of the day applications, I created a way to get a random quote. So let me blow that up a little bit so that's actually readable. And then you can do a refresh, get different quotes, all well and good. But then it comes to an edge service. And our edge service, we need to also do a couple of things. One, we define different endpoints. Typically with an edge service, you write specifically to accommodate mobile devices. You want to collect marshal and unmarshal inputs and outputs, if you will, to your backing services so that your mobile device only has to hit one single point and then it handles all of the massaging of the information back and forth. Wow, I'm close on time, so let me just kind of summarize it like this. You can also incorporate message queues for asynchronous processing. Certainly reactive programming is a big deal. It's a very important tool in your tool belt. But even within your corporate settings, you probably already have some kind of message queues in place. You can take advantage of that now with things like Spring Cloud Stream as well. So if we go here, and let's take a look at our edge service, What this does is via Zool, it will translate that call to the backing service. You can also do a straight pass-through. So again, you can do what's called a microproxy very easily and quickly. These are things that you implement or will need to implement in some fashion to support a microservices approach. This makes it very easy because, again, and let me go back over here to Eureka and bring that back down where it's a little more readable. As you can see here, we have an instance of each, our edge service and quote service showing up. One thing that I didn't show, which I would like to, is the fact that, and I kind of, I go through a little extra pain and hassle just to be able to show this particular example. It's not something you typically do in production, but everything, if you notice, is routed based on your service name as logged with Eureka. So in your service registry, you are now contacting and dealing with, interacting with other microservices based on their service name. You don't have to know or care where they're located. You don't have to go through a lot of complicated steps to determine what your container is or what your port number is. It's a simple matter of allowing your registry to do the undifferentiated heavy lifting for you. So while microservices add some complexity, there are a lot of tools you can bring to bear to simplify that back down and allow you to, again, get the velocity you need. So I'm really close on time. I made it under the time limit. Does anybody have any quick questions before we call it a day? Anyone? Yes?
I see the quote service, but
yes.
How your computer knows that to which IP it resolves? Because it was DNS name, right?
To which IP, you said?
I see it's HTTP semicolon / quote service. So how it knows to which IP it resolves? It registers in the DNS or it's added to your DNS?
No, because actually DNS is actually rather clunky when it comes to in terms of dealing with cloud instances. It can be spun up and spun down on demand or just due to crashes. That's what your service registry is for. As long as you register your microservice with your service registry, it will pull that service registry and cache those results. Again, you want client-side caching because if anything, heaven forbid, were to happen to that service registry, you still want your downstream, if you will, microservices to continue running. And then once that comes back online, it reestablishes and updates its cache. So it uses that service registry for the IP addresses and port numbers it needs to find its backing microservices.
So REST template was somehow tuned to use the service registry, not plain DNS lookup?
Yes, actually, and I was going to show this, and again, time. Because what I did was inject a particular, a REST template. And the fact that we are using a Zool proxy, which again, this is all Netflix OSS and Spring Cloud OSS, it allows you to load balance that so you can reach out and via round robin by default, access any instance of the microservice in question that you specify, again, by service name.
I see, thanks.
Yeah, you're welcome. Anything else? Yes?
Hi. Okay, so if your business rules are going to span multiple bounded contexts, well, firstly, is that allowed, or is it expected that your business rules must be fully encapsulated within one bounded context?
That gets rather tricky, doesn't it? Because
I mean, where I'm going with that then is you either say, okay, your business rules must be within one bounded context, and that's how we will define our bounded context. But then you could spend 6 months doing that, and then a new business rule comes in, and it crosses 4, 5, 6 different bounded contexts. So do you then impose back on the business that, well, no, your business rule cannot. We've defined our bounded context, and now this is how we operate from this point forward?
Well, I mean, it's almost impossible to do that, isn't it? I mean, you're going to have some processes that are going to I'm sorry, I'm getting the getting the notification. You're going to have some processes that are going to span various different microservices. So various contexts you're going to have to cross. But this is why you have, and again, I gave a nod to it earlier on the better architects. You're going to have somebody who can reason about those and determine how best to assemble those microservices in what order in order to make that process, fulfill that process. So you're going to have certain processes that are encapsulated or captured outside of a particular microservice or group of microservices, but typically you're going to have to maintain that externally to those. The nice thing about microservices is I almost equate it to Legos. You can bring them in different orders in order to build the outcome that you need. So you can, if something changes within your environment, you can swap them out. You can add an additional subscriber to a queue. So we didn't really even get into the topics versus queues thing, but you have flexibility in that regard because the microservices, in effect, you compose your business process versus having to code it into your monolith directly. Did that help?
A little.
Okay. Ping me after the fact. Again, the best discussions usually happen afterward because that's when you start thinking about it and kicking things around, and very happy to continue the conversation. Please do give me feedback. Let me know if there are things, again, I'm trying to get this balance just where I want it, and I've never been 100% happy, but I think I'm getting closer. So please let me know. Was this helpful? Good, bad? Anything? Did you like it? Okay.